Hello students, welcome to Academic Aura. Today we will begin with chapter 5 GCD and LCM for standard 6. Okay, this practice set is practice set 5.1. Now before we begin with the first practice set, just understand what is GCD and LCM. Okay, now GCD means the greatest common divisor, and LCM least common multiple. Okay, now for this practice set you only need to learn what is a divisor and what is a multiple. Later in the next practice set we will learn what is the greatest common divisor and what is the least common multiple, that is GCD and LCM. We have to find the GCD and we have to find the LCM, but for the first practice set 5.1, just know what is a divisor and what is a multiple. Now see, what is a divisor? Suppose they give you a number like 42, okay, and when you divide 42, and suppose if I say 6 is the divisor, okay, 6 is the divisor over here. 6 7 is 42, and then when you divide it you are getting 0 as the remainder. Okay, so when your remainder is 0, when a number is divided by another number and no remainder is formed, is called a divisor. That means 6 is the divisor of 42. Understood? 6 is called the divisor of 42 because there is no remainder. Understood? So 6 is called the divisor. Understood what is the divisor? Same if I take 42 again, I take 7. Again 7 6 are 42, 0, 0. Again you are getting 0. That means even 7 is the divisor. 7 is, you can divide, right, by 42. 42 is divisible by 7. That means even 7, 6, 7. Even if I take 42 and 2 over here. So 2 2s are 4. 4 minus 4 0, get this 2 down, 2 1s are 2, 2 minus 2 0, again I'm getting the remainder 0. That means 2 is also a divisor. Which are the different divisors of 42? So you will get more if you factorize this. Okay, so 42 you can also factorize 42. See, this is the factorization method. What is the last number? 2. So you can take in 2 times table. 2 2s are 4, 2 1s are 2. Now again last number is not 0, 2 4 6 8, we can take in 3. 3 7s are 21 and 7 1s are 7. So if I see here, what are the divisors? 2, 3, 7, 21 and even 1 and 42. Understood? You also have to take 1 and 42, the number itself. So all these are the divisors of 42. Understood? How you will take, what are the divisors of 42? 1, 2, 3, 7, 21 and 42. Understood what is a divisor? The divisor is also called as a factor. These are all the factors of 42. Now see multiple. If I say multiple of 3, what are the multiples of 3? So you know 3 times table. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15. Same way multiple of 5. 5 1s are 5, 5 2s are 10, 5 3s are 15, 20, 25. These are the multiples. Understood? Multiples of 3 and multiples of 5. Divisors you understood. So let's begin with the practice set. Now see here, write each number as a product of the prime factors. You have to first find out the prime factors. Okay, product means multiplication. Product means multiplication. You have to multiply of prime factors. Now I'll tell you, factors means the divisors only. I showed you when I was explaining 42 factorization. So first what we will do is factorize 69. First I am doing the vertical method. I will everywhere do the vertical method and then I will show you the horizontal method. Okay. So first 69, do the vertical method first. Now see here, see the last number. Always see the last number. If you have 0, 2, 4, 6, 8, then only you can take 2 times table. Otherwise you should check in other table. So I am taking 3 over here. 3 2s are 6, 3 2s are 6. And 3 3s are 9. Understood? 3 2s are 6, 3 3s are 9. Now see 23. 23 is a prime number which doesn't go in any table. So we cannot take any other table. Only 23 1s are 23. Understood? So this is the vertical method. So what are the factors? I told you in the example when I was explaining, I told you these are the factors. 3, 23, 1 and 69. But over here, for this we are only going to write 3 and 23. Okay, so the factors of 69, what are the factors of 69? Only 3 and 23. So just write 3 and 23. Understood? So 3 and 23 are the factors of 69. The same way, now the horizontal arrangement, write 69 as it is. Now see here, what are the factors of 69? 3 and 23. Just 3 and 23. That is only the answer. Only 3 and 23. Now 23 is a prime number. You cannot split it again. Okay. So 23 will be as it is. So 3 and 23 only are the factors of 69 in the horizontal arrangement. And in the vertical arrangement, 3 and 23 you get like this. Understood? This is the horizontal arrangement and this is the vertical arrangement. Okay. Now see the next sum. Now see in the next sum we have 27. Okay. 27 also the same way. First we will do the vertical arrangement. 27. Write 27 as it is. And then check the last number. What is the last number given here? The last number is 7. So you cannot take 2 times table over here. We can take 3. Okay, because 27 is divisible by 3. So we will take 3. 3 words are 27. 3 nines are 27. 3 nines are 27. Again we got 9. 9 is not divisible by 2. Again 9 is divisible by 3. So 3 words are 9. 3 threes are 9. Understood? 3 threes are 9. And then again 3 ones are 3. So this is we have factorized by vertical arrangement. So write the factors of 27 now. Prime factors they have said. So 27, what are the prime factors here? See, these are the factors. 3, 3 and 3. So we will say 3, 3 and 3. Understood? This is how we write the prime factors. Same way look at this and do this. Okay. Now see this. For the horizontal arrangement, write 27 as it is. First, what did we take? 3 nines are 27. Look at this first. This thing. What did we take? 3 nines are 27. Right? 3 nines are. So first just write 3 multiplied by 9. Okay? 3 nines are 27. Next step is get this 3 down. 9. How did we split 9? 3 threes are 9. Okay? First 3 nines are 27. So write 3 multiplied by 9. Next 3 bring down as it is. 3 threes are 9. So instead of 9 we will write 3 threes are 9. Understood? Now last number 3 is a prime number. You cannot split again. You cannot take any factor again. So we have 3 into 3 into 3 and 3 into 3 into 3. Both the sides are same. Understood? So these are the factors of 27 here. So this is by horizontal arrangement you get, and this is by vertical arrangement. Understood? Now see in the exam, some schools, some teachers ask for both the methods. Some say that you can do any method. Okay, so it is necessary to know both the methods. In the exam, they might tell you either do it by horizontal method. They might mention find the prime factors by horizontal method or find it by vertical method. Okay, so both the methods you should know. Now we have finished the second sum here. Okay, see the third one. Horizontal arrangement and vertical arrangement. Okay, now horizontal arrangement, vertical arrangement I am doing it first. 78. Okay, so first we will factorize 78. Now see in 78, what is the last number? Last number is 8. When you have, I told you 0, 2, 4, 6, 8, we will begin with 2 times table. Okay, now in this, see here, in this less than 7 in 2 times table is 2 threes are 6. 2 threes are 6 in 7 times table. Sorry, 2 threes are 6 in 7. Okay, less than 7. If 2 threes are 6, how much is left? 1 is left. You carry 1. It becomes 18. 18, so 2 nines are 18. Understood? 2 threes are 6 in 7. 1 is left. Carry 1. 2 nines are 18. Now see the last number is 9. You cannot divide it by 2. That means we will have to take 3 here. 3 ones are 3 and 3 threes are 9. 3 ones are 3. 3 threes are 9. 13 is a prime number. When it doesn't go in any table, you have to take the number itself, the same number. 13 ones are 13. Understood? So we have got the factors of 78. These are the factors of 78. 2, 3, 13. So factors of 78 are 2 into 3 into 13. Understood? Now see the horizontal arrangement. Looking at this only, we will solve this. 2 and 39. First write 78. What is the first one? 2 multiplied by 39. 2 multiplied by 39. Next step, bring this 2 as it is, and 39. 39. How you get 39? 3 13s are 39. How you got 39? 3 13s are. So instead of 39, we will write 3 13s are is also 39, right? So instead of 39, we will write 3 13s are 39. Now 39, last number. You should always see last number is a prime number which doesn't go in any table. That means these only are the factors. Understood? So here also we got 2 3 13, 2 3 13. Answer will be the same, but methods are different. Okay, so this is the answer for 78. 2 3 13 are the prime factors. Here also it is the same. Understood? Children, if you are new to my channel, please do subscribe for more videos. Now see the next one. 126. Okay, we have 126 here. Again, we will first do the vertical method. Now what is our last number? Our last number is 126. Last number is 6, sorry. So 6, again we will take 2 times table. 2 less than 12, what will you take? 2 6 are 12 and 2 3s are 6. Understood? 2 6 are 12, 2 3s are 6. Now last number is 3. We cannot take 2. We can take 3. 3 2s are 6. 3 1s are 3. 3 2s are 6. 3 1s are 3. Again 21 is divisible by 3. 3 7s are 21. Now see the last number 7. 7 doesn't go in any table. It is a prime number. That means we will take the number itself. 7 1s are 7. Understood? So what are the factors we will write here for 126? Factors of 126, see this on the left hand side. 2 3 3 7. So these are the factors of 126. Now looking at this, we will do the horizontal arrangement. Write 126 as it is. Now first for 126, which two factors we took? 2 multiplied by 63. First we will take 2 multiplied by 63. Next step, get this 2 down, and now 63. How did we get 63? 3 21s are 63. 3 multiplied by 21. So instead of 63, 3 multiplied by 21. Now next step, see 21 again we got how? 3 7s are 21. So we cannot stop here. We have to do it again. So what we will do? Get this 2 and 3 down. Now instead of 21, what we will take? 3 7s are 21. 3 7s are 21. Understood? For 21, how did we get 21? 3 7s are 21. Now, again you don't have to write 7, only once. 3 7s are 21 because here 7 is a prime number. Okay, it doesn't go in any table. We have to stop there. So, see both the side answers are same, 2, 3, 3 and 7. So, this is your factorization for horizontal method and this is your factorization for vertical method. Okay. Now see in the second one, write all the divisors of each of the following numbers. We only have to write the divisors. When I was explaining at the beginning, I showed you how to write all the divisors, including 1 and the number itself, that is 18. We have to write each and every divisor including 1 and 18. For this, just now for the vertical arrangement, what we did, that step we are going to do, okay, everywhere, so that we get all the divisors. Now suppose for 18 you first factorize it. First factorize 18. So when you factorize, you get each and every divisor. If you don't factorize, sometimes you will forget to write some of the divisors in between. Okay, so it's better to factorize first and then you write. Now see, as I told you, last number is 02468. What will you take? 2 times table. 2 9s are 18, right? 2 9s are 18. Will 9 again go in 2 times table? No, it is not divisible by 2. So we will take 3. 3 3s are 9. Understood? Again 3 is a prime number. It doesn't go in any table. Okay, so it is 3 1s are 3. Understood? 2 9s are 18. Then 3 3s are 9 and then 3 1s are 3. Now see how to write the prime factors. Okay, not the prime factors. The prime factors is only this 2 into 3 into 3. But we don't want all this. We want all the divisors. Okay, so to write all the divisors, I told you first you have to always write 1. 1 then we have 2, then we have 3. Do we have 4 over here anywhere? No, 4 is not there. Do we have 5? No, 5 is also not there. 6, see 6 is not there, but you can multiply these factors, okay? See, these are the prime factors. We can multiply these and we can get 2 3s are 6, okay? 2 3s are 6, that means we are getting 6 also. 7 is there? No. 8 is there? No. You can see, even I told you can multiply. So 3 3s are 9 and 9 is there over here also. So we can take 9 also, okay? So 8 is not there even after multiplying the two factors, but we are getting 9. 9 is there. So write 9 and then 18 itself and 18, okay? So these numbers are the divisors. You can write are the divisors of 18. Understood how to write all the divisors? So that's why I'm telling you that factorize it first so that you get each and every divisor. Now see, the next number is 56. Now for 56, again we are going to factorize it, okay? So factorize 56. First thing is we will factorize 56. Again, what is the last number? Last number is 6. 0, 2, 4, 6, 8 means we can take 2 times table. Now see, it is a big number. You can take one number. Here, see here. So less than 5. In 2 times table, less than 5 is 2 2s are 4, right? So we will take 2 2s are 4 in this, okay? 2 2s are 4 in this. How much is remaining? If 2 2s are 4, okay, from 5, 2 2s are 4, so 1 is remaining. 1 you carry it on the next number, carry it to the next number. That becomes 16. So 2 8s are 16. Understood? 2 2s are 4 in this. 1 is remaining. You carry to the next number. It becomes 16 and 2 8s are 16. Again the same step. Last number is 8. Again 2. 2 1s are 2 and 2 4s are 8. Last number is 4. Again 2. 2 7s are 14. Now we have 7. 7 is a prime number only in the number itself. 7 1s are 7. So we got all the prime. We got all the divisors in this, okay? See how to write it now, sir. First is 1 and we have 2. So we will write 1, 2. We don't have 3 anywhere over here. 3 is not there. 4 is there. Now you will say 4 is not there over here, but I told you you can multiply the factors. 2 2s are 4. So even 4 is a divisor. 4, 6, 5 is not there. 6 is also not there. See, even if you multiply, you are not getting 6. 2 2s are 4, 4 2s are 8. 8 is there. That means 2 2s are 4, 4 2s are 8. 8 is a divisor, okay? So 5 and 6 is not there. We have 7 and we got 8 also here. 2 2s are 4, 4 2s are 8. So we will write 7 and 8. Understood? 7 and 8. Then you can write, see, 2 7s is 14. When you multiply 2 and 14 is also given over here. So we can write 14. After 14 we have 28 and 56. 14, 28 and the number itself also you have to write 56 are the divisors of 56. Understood this sum? See the next sum, 120. Now for 120, again we are going to factorize 120. So factorize 120 as I told you, 120. What is our last number? Last number is 0. That means we can start with 2 times table. 2 6s are 12. Okay, 2 6s are 12 and 2 zeros are 0. Again 0 at last. Again we can take 2. 2 3s are 6 and again 2 zeros are 0. Again we can take 2. 2 1s are 2 in this. Okay, 2 less than 3 in 2 times table. Less than 3, 2 1s are 2. 2 1s are 2. How much is left from 3? 1 is left. So 2 5s are 10. Now see, it's 15. Can you take 2 again? No, we cannot take 2 again. We can take 3. 3 5s are 15. Okay, 3 5s are 15. Now 5 doesn't go in any table. We have to take the number itself. 5 1s are 5. So we are done with the factorization. Now we will get each and every divisor of 120. So let's start writing the divisors. 1 2 3. 1 2 3. 4 also we have. I told you can multiply these factors at the side. 2 2s are 4. That means we have 4 and we have 5 also. Now next is 6. We have 6. You can multiply in between any divisor and you can get the prime, you can get the divisor. 2 3s is 6. You can see here the factors are 2 and 3. So if you multiply 2 3s 6, that means 6 is also a divisor. Now see here 7 is not there, and even if you multiply these factors you cannot get 7. Okay, then 8, yes, you are getting 8. How? 2 into 2, 2 multiplied by 2, 2 2s are 4 and 4 2s are 8. That means we are getting 8 also. 9, we are not getting 9 even if we multiply. There is only 3 here. If we had another 3, we could multiply 3 3s are 9. Only 1 3 is there, so we are not getting 9. Understood? Now 10, we will see there is no 10, but we can multiply, and since the last number is 0, that means it is divisible by 10. Always whenever you have 0 in the units place, it is divisible by 10. Otherwise here 2 5s are, when you multiply these factors, 2 5s are is 10. That means you are getting 10 also as the divisor. After 10, does it go in 11? No. 12, yes, it will go. How? 2 2s are 4, 4 3s are 12. Understood? See here, 2 2s are 4. Multiply these. 2 2s are 4 and 4 3s are is 12. So we are getting 12 also. 13 is not going. 14 is not going. 15 we have here. See here, we have 15, right? So that means 15 is going. So we can write 15 here. Understood? Next, after 15, you can also multiply and check this. 2 2s are 4, 4 2s are 8. Okay, see here, 2 2s are 4, 4 2s are 8, 8 3s are 24. That means even 24 is going. So see, so if you don't do it, don't factorize it, you will miss the divisors. Okay, so 2 2s are 4, 4 2s are 8, 8 3s are 24. So even you have to write 24 also. Now after 24, 5 3s are 15, 15 2s are 30. Okay, 5 3s are 15, 15 2s are 30. 30 is there here also, so you can write 30. Then we have 60, and last is 120. That is the number itself. So understood why it is necessary to factorize, so that you get each and every divisor of 120. So and 120 are the divisors of 120. Understood? Now see 256. Now same way we are going to factorize 256. So see here 256. Last number is what? 6. Again, so that means we can take 2 times table. 2 1s are 2. Okay, 2 1s are 2. Next number 5. Less than 5 in 2 times table is 2 2s are 4. Okay, we cannot take 6 because it will be more than 5. So we can take 2 2s are 4. 2 2s are 4 in this. Okay, 2 2s are 4 in this. If 4 is there in this, how much is remaining? 1 is remaining. Carry 1 to the next number, that becomes 16. 16 is divisible by 2. 2 8s are 16. Again, last number is 8. Again in 2 times table, 2 6s are 12. Okay, 2 6s are 12 and 2 4s are 8. Again the last number is 4. Again we can take 2. 2 3s are 6 and 2 2s are 4. Okay, 2 3s are 6, 2 2s are 4. Last number again 2. Less than 3 in 2 times table. Okay, we cannot take 4. 4 will be more. So we want less than that. So 2 1s are 2 in this. Okay, 2 1s are 2. How much is left? 1 is left. Carry to the next number, it becomes 12. 2 6s are 12. Again we can take 2. 2 8s are 16. Right? 2 8s are 16. 2 4s are 8. 2 2s are 4. And then 2 1s are 2. Okay, so see here 2 2 2 everywhere 2 only. Why I am taking the smallest one? So that you all get each and every divisor of 256. So see here we have factorized. Now very carefully find out each and every divisor of 256. First one is 1. 1 2 is there. Okay, 1 and 2 is there. 1 2. Can you see 3 anywhere over here? Even inside you can see 3. No. Even in the factors you can see no 3. But you have 4 over here. 4 is there. Do we have 5? No. Do we have 6? No. We don't have 6 also. Okay. So 5 6 is not there. Even if you multiply here, you are not going to get 6 because 3 is only not there. So 3 2s would be 6. But 3 is also not there. So we don't have 6. Do we have 7? No. But we can take 8. How we can take 8? 2 2s are 4, 4 2s are 8. Okay, 2 2s are 4 and 4 2s are is 8. So we get 8 also here. Next, after 8, see again, 2 2s are 4, 4 2s are 8, 8 2s are 16. 16 is over here also. After that, 32 we have. Okay, we have next number is 32. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. 32, then we have 64. You can see, take this also. I took 2, 4, 8, 16, 32, 64, 128 and 256. So 32, 64, 128 and the number itself and 256 are the divisors of 256. Okay. Now see the last one is 67. Now 67 doesn't go in any table. Okay. 67 doesn't go in any table. It is a prime number. That means it only goes in 1 and the number itself. So see, even if you factorize it, you don't have to factorize, but I'm just showing you 67. Even if you factorize it, you will only get, it is going in the number itself. 67 ones are only 67. Doesn't go in any table. Okay. So what are the factors? 1 and 67. Now you can also write that 67 is a prime number. Therefore, the factors, you can say the divisors of 67 are 1 and 67. So only write 1 and 67 are the divisors of 67 as it is a prime number. Understood? So whenever you get a prime number like 67, 23, 41, these numbers do not go in any table. They only go in 1 and the number itself. So we have to say the same number, that is 1 and 67 are the divisors of 67 as it is a prime number. Okay, understood here? So we have finished this practice set 5.1. If you have still not subscribed to my channel, please do it so that you get more new videos. Thank you for watching.